Hello friends, welcome to the channel Debug the Dreams, and we are seeing the virtual memory. Last chapter we have seen what is the problem with the physical memory. So to solution to that is virtual memory, and obviously how that solution works, that we are going to see in this chapter. Okay, so let's start. So what is big idea behind this? To solve the problems. So idea is that give each program its virtual memory, so that each program will see that as its own, and it will be isolated. Like consider VS Code is having 4 GB of memory, Excel is having 4 GB of memory, and Teams is having 4 GB of memory, but reality you have physical RAM of 2 GB. So there is one more, we will use the swap space from the disk, so that one more memory is available, and that will be utilized as a supporting memory to the your RAM, and we are going to solve the problem of limited memory. How it's going to solve our problem? It's like a running program is given the illusion of having its own memory. That is like if your architecture is 32 GB, 2 raised to 32 address space is given to you, or if you are 64-bit system, then you have given the 2 raised to 64 addresses to be used as a your own virtual address space. Okay, so our first problem was like not enough memory. So how to solve that? So first let's look at the problem. We will not have we will map the addresses 0 to 1 into the physical memory. So you can see in this animation that like we are mapping 1 to 1 for first 4 addresses, but the fifth one is not having enough memory to get mapped. So when it's mapped to that memory, it will obviously crash. So how to solve that? We will put one map in between. So virtual memory goes to that map, check what is the physical address is there to map the virtual address, and we will go to the physical memory either, or we will go to swap space. So this is how we will solve the first problem. So our second problem is fragmentation. So suppose there is one program which requires 2 GB continuous memory, which is virtual memory, right? So obviously we have map in between. Now OS is taking care of that. So, and we have the fragmented space. Suppose the 1 GB is there in middle of the Teams and Teams and Edge, and 1 GB is down at the your RAM. So we will divide our program. We will means OS will divide our program into 1 GB in middle it will put, and another 1 GB it will put into the another space that is down. Okay, so this is how we will solve the fragmentation problem. And the third problem is security. Let's suppose now two programs is running. One is a game and another is a bank application. Those is the same virtual addresses. So virtual addresses always you will get virtual addresses from 0 to 2 raised to 32 either, or 2 raised to 64. So they obviously will have the same addresses. So if they are individually using the 64 address, one is storing score at that address, one is storing balance at that address. So that addresses actually are now going to map to the different addresses of the physical memory, and with the help of our translation map we are going to solve that problem, and individual process will not interfere with another process memory. So that problem is also going to solve the problem. So now let's have a look at the complete virtual memory system, how it is going to work. So let's have a look at this animation. We have the 4 program running. One is Team, one is Edge, one is VS Code, and one is Excel. Each will have the 4 GB of virtual memory, as we are considering 32 bit of system, and it's working with the OS translation layer and the physical RAM as well as the disk swap space. So just all the pages are continuously going into the RAM. Then once the RAM is got filled up, it's swapping the pages into the swap space. So that's what it's going on currently, and this is the how OS translation works. So transferring the data from the swap to translation layer or the RAM is very slow. Obviously it's going to be slow because the bandwidth is very less in towards the disk. So Finally, let's summarize what we have got from this magical idea. Every program it so from this magical idea what we got. So every program gets its own universe, solves the memory shortage problem. There will be no fragmentation as we have the map in between. So we will utilize the memory efficiently, and there will be last benefit, which is we are isolating the programs from each other. Those will not interfere with each other. So now the burning question is that how does the iOS actually does this? So we are going to see that in the next chapter. That chapter name will be page and page tables. Okay, thank you for the watching. Please do subscribe the channel if you are liking this series. Thank you for the watching.